All right, guys, here is the start of Wednesday's lesson for Wednesday, April 28th. We are talking about inverse sine, cosine, and tangent. And when we are finding inverse sine, cosine, and tangent, we are finding or using the principal root. And those principal roots are in the domain and range that we would have of those inverse functions. What we saw last week on Wednesday's video and then building on to on Thursday and Friday is where we found the quadrants for the principal roots. So arc sine, remember our area that we're looking at for arc sine is negative pi over 2 to a positive pi over 2. And that's quadrants 1 and 4. Then cosine, we were looking at those between 0 and pi. So that's quadrants 1 and 2. And then tangent was more like sine, so we're back to negative pi over 2 to a positive pi over 2. And that, again, is quadrants 1 and quadrants 4. And what's important about these is we know where sine, cosine, and tangent are all positive or negative in these different quadrants. But this is where we find the principal roots. And principal roots are just one solution for the angle within those domains that we've given. So if you're asked to solve using inverse functions, what are the principal roots of the following equations? So if we think about sine, between negative pi and pi over 2, the only place that sine is positive is in quadrant 1. And so somewhere out here at quadrant 1 is we have an x value and our y value for sine is 1/2. And that value there, where y is 1/2, is where x was root 3 over 2. And so x in this case is going to be pi over 6. Same again, if we're looking for cosine of x is negative root 3 over 2, and we know that cosine is in quadrant 1 or quadrant 2, cosine is only negative in quadrant 2. So if we wanted to find the arc cosine, again, we saw this was pi over 6. This reference angle here is pi over 6. What we are looking for is this angle, or x. And that angle is going to be 5 pi over 6. And following number 4 is we want to know where tangent of x is 0. We know that tangent is y over x, and so we need to know where y is 0, and whenever y is 0, x is either 1 or negative 1. So where tangent is 0 is out here on the unit circle at this point 1, 0. We're only going to use this root here because it is in between quadrants 1 and quadrant 4. Over here, tangent would be 0 as well, but we don't care about that one. So x here is also 0. So what we are really doing here is we are really finding the inverse of sine of 1/2, and that is pi over 6. Or you could say, what is the arc cosine or arc sine of negative root 3 over 2. Those are both very equivalent statements, and that is 5 pi over 6. Or we could have tangent to the negative 1, going back to that original nomenclature of 0, and that equals 0 as well. Right. Those are our principal roots. One other thing we want to do is, and we've done this before, is where are all the solutions in the interval 0 to 2 pi? And you should remember for sine, cosine, and tangent, we're going to find the value of sine x equals 1/2 in two different places. And same with cosine equals -√3/2, and the same with tangent is 0. So we know for sine of 1/2, if we want to find it for where it equals both answers in 0 to 2 pi, we know that sine is also positive over here in quadrant 2, and that this must be pi over 6 as well. So then my other value between 0 and 2 pi, my two solutions there must be this pi over 6 and 5 pi over 6. Same with cosine. Cosine is also -√3/2 in quadrant 3 with a reference angle of pi over 6 there. So we know in the interval 0 to 2 pi that one of our solutions was 5 pi over 6. That's the one in quadrant 2. But in quadrant 3, we can also add 7 pi over 6. And again, for tangent over here at -1, 0 would also be 0. And that's at pi. So we know that between 0 and 2 pi, we have the values of 0, and pi is where tangent equals 0. All right. So here is finding all the solutions for inverse trig. Either principal roots, which is 1, has to be in the given domains of our one-to-one function, or between 0 and 2 pi, we're going to have two values. And on the next video, we're going to talk about finding those same values for every time sine equals 1/2, or every time cosine equals -√3/2.